All right, let's dive right into this explainer. Today, we're going down into the trenches of enterprise IT to explore three real-world battles. We're going to look closely at those hidden, incredibly frustrating technical issues that can completely derail a massive project and exactly how elite engineers actually step in to solve them.
Because let's face it, when you're dealing with massive enterprise infrastructure, the stakes are literally always high. We're looking at how analytical thinking, combined with modern tech, solves these incredibly complex operational bottlenecks. And here's the thing. Relying on assumptions in these scenarios almost always leads to failure. I mean, it's so tempting to just guess what's going wrong when a system crashes, right? But as we'll see today, guessing is absolutely the enemy of good engineers.
So here is our roadmap for today. We've got four main stops. First, the Hitachi 64-bit error. Second, National Data Center automation. Third, the Conbank RAG optimization. And finally, we'll wrap up with our key takeaways. Let's get to it.
Kicking things off with Section 1, the Hitachi 64-bit error, debugging legacy systems under pressure. Picture this. There's a ticking clock on a massive Honda project deadline at Hitachi. The final step, literally the crucial analysis tool that generates the project files, starts failing, throwing a completely unknown error. And this system was old. No one on the team had any idea why it was failing right at the finish line. Naturally, panic usually sets in right about here. In fact, the manager just assumed they should tear it down, rebuild a project, and try running the whole analysis all over again. But the engineer on this project, they pushed back. Instead of just blindly trying the exact same thing twice, hoping for a different result, they paused the immediate rebuild. They asked for just a few minutes to validate a totally different approach. They dug deep into the internal docs and realized that the logging for this specific legacy environment had never actually been properly turned on. So, they flipped the switch, enabled the logging, executed the analysis, and actually gathered real data.
And wow, once that logging was enabled, we get this dramatic reveal. It turned out a newly introduced data type in the project was a 64-bit long integer. And get this, the old analysis tool simply did not support it. That was it. Without those logs, the team literally could have spent days rebuilding and guessing in the dark. But with the logs, it required one tiny specific modification, and the project was successfully delivered right on schedule.
So, the absolute crucial point here is that relying on empirical evidence, rather than authority or assumptions, is what actually saves time when the pressure is on. The engineer had to influence their manager without having direct authority, right? And they pulled it off by championing data over dogma. That is exactly how you troubleshoot effectively in the real world.
Moving right along to Section 2, National Data Center Automation, transitioning from manual VPNs to standard APIs.
Okay, so over at the National Data Center, a government organization frequently needed operational data for their analysis. But under their old workflow, this process was, frankly, incredibly painful. Engineers had to manually prepare query results and then, get this, physically transfer that data through a clunky VPN connection back to the organization. It was time-consuming, it was manual, and it was highly inefficient. So what was the proposed solution? Scrap all that manual labor and replace it with a sleek, fully automated API response system.
But hey, as we all know, having a brilliant technical idea is really only half the battle, right? You still have to sell it. The engineer first got manager approval on day one, but then came the hard part, pitching this to non-technical government stakeholders. By communicating the value incredibly simply, focusing heavily on how automation would improve their speed and slash their manual busywork rather than, getting bogged down in complex API architecture, they secured enthusiastic stakeholder buy-in by day 3. They then built and tested the entire solution in a ridiculously rapid 2-week window. By week 3, the previously frustrated organization was actually sending them an appreciation email, a total game changer.
All right, let's step it up for Section 3. Conbank RSUG optimization, engineering reliable AI.
Now we are escalating to arguably the most complex challenge, cutting-edge generative AI. At Conbank, the engineering team desperately needed an internal AI chatbot that they could actually trust to help them troubleshoot incredibly complex banking systems. But to understand how they fixed it, we gotta understand the setup. Their old internal knowledge base relied heavily on exact keyword matching, which was completely failing. If a user searched using even slightly different terminology than what was hard-coded in the database, they got absolutely nothing. To fix this, they brought in a Retrieval Augmented Generation, or RAG, architecture. This uses semantic similarity to understand the actual meaning behind the search, retrieving the relevant context even if those exact keywords don't match up.
But here's the catch. RAG systems introduce a whole new, massive problem: reliability.
When engineers are using a tool to troubleshoot critical banking infrastructure, the AI simply cannot hallucinate, period. So to fix these reliability issues, the team deployed 3 super-specific algorithmic optimizations. First off, they strictly restricted the large language model to only use the retrieved context. But the real magic? That was in the chunking. See, sometimes important contextual data was getting split right across chunk boundaries during the semantic search, basically causing the AI to miss vital pieces of the puzzle. By carefully tuning the chunk size and specifically implementing overlapping chunks, they ensured literally no context was ever lost in the margins.
And this number right here, 0.0, this is everything. In the wild world of LLMs, the temperature parameter controls creativity. A higher number gives you more creative, unpredictable text. By dialing it down to exactly 0.0, they absolutely minimized hallucination, effectively forcing the model to act as a strict deterministic engine. This was the key to ensuring absolute trustworthiness for the engineers who were relying on it.
We can actually pop the hood here and look at the exact system prompt hard-coded into their architecture. Look at how incredibly authoritative this is. Rule 1, answer using only facts explicitly stated. Rule 2, do not use outside knowledge. And Rule 3 provides a strict hard-coded fallback string if the answer just isn't there. Guys, this isn't just asking the AI nicely, this is engineering absolute ironclad guardrails so the AI functions as a reliable enterprise tool, not some creative writing assistant.
Bringing it home with Section 4, Key Takeaways, the Engineer's Playbook.
Let's pull all of this together and look at the overarching lessons from these 3 very distinct technical battlegrounds. Whether you're debugging a stubborn legacy analysis tool, replacing manual VPN tasks with automated APIs, or crafting bulletproof RAG system prompts, these 3 pillars absolutely dictate your success. Number 1, you must prioritize logs and empirical data over guessing. Number 2, you have to translate technical efficiency into real business value so stakeholders actually let you build the solution. And number 3, when it comes to AI, you have to architect it for strict reliability, minimizing creativity in favor of cold, hard, factual accuracy.
So as we wrap up this explainer, I want you to ask yourself how you're approaching your own enterprise challenges today. Are you blindly guessing at the root cause, or are you pulling the logs? Are you building overlapping chunks to ensure your AI actually has the full picture? Because the difference between a system failing and a system scaling almost always comes down to the strategy of the engineer sitting right behind the keyboard. Thanks for joining me on this deep dive, and I'll catch you next time.